Okay, so this is the first day of our first chapter that's actually out of the book. If you brought your book, great. I told you to bring your book, so way to go, you remembered. If you didn't bring your book, though, we actually are using a worksheet today. Like I told you guys, this is our first time teaching this. So some of this stuff we already have, like these really good worksheets that we love that go right along with the book, and we'll use those. Some days we don't have those worksheets, so we'll assign homework out of the book. It's just kind of going to be a mix and match year until we can sort of figure out which way we like to do it. So you guys are kind of our guinea pigs. The good news is that algebra is pretty much always algebra. So whether it's from the book or a worksheet, you're going to be doing the same types of questions. So that's not a huge surprise there. And you all have a notes packet, so you can sort of preview what's coming for the rest of the chapter if you're super curious. This is, and I say this with absolute confidence, the most important thing you will learn in algebra class. Okay, solving equations is pretty much the backbone of algebra. You use it in every single math class to come. So today's the big day. All right, you guys excited? Today is also the day where you get to use a calculator. So if you brought a calculator, you can get it out. If you don't have a calculator, the only day I lend calculators out are quiz and test days. So, and you are not allowed to use phone calculators in this class. So, it's time to either just commit to paper and pencil, like old school multiplying and dividing and such, or go and spend the $12 on the calculator. All right, mine that I lend out are kind of just for emergencies if you forgot it on quiz or test day. If not, you're just kind of on your own. So we are going to jump right into examples. I am sure you all have experience with this type of question, so it shouldn't feel super new to you. We solve equations by isolating the variable. Do you guys know what the word isolate means? Yes. By itself. So we want to get the x part by itself. We get x's by themselves, or variables in general by themselves, using inverse operations. Those are operations that undo each other. So what will undo a subtracting of 7? An adding of 7. And this is like a balance. I always think of like the lady. It's always on like law, like in courthouses and such, like a balance beam. If you're putting weight on one side, you got to put the weight on the other side if you want that lady's arms to that. You know what I'm talking about? I feel like I'm describing this terribly. You got to watch though,
The scales.
Yes. So if you're adding 7 to one side of the scale, you got to add 7 to the other side of the scale if you want it to be balanced. The equal sign is where we're balancing it. Okay, that's the middle. So if you add 7 to the left, you got to add 7 to the right. The 7s go away. You can cross them out. I'm left with just the x. And then on the right side, that's where you actually have to do the math. So -5 plus 7, if it's not something you're interested in doing in your head, that calculator's going to be great. I do think you can all handle this one, though. It's basically 7 minus 5, which is 2. Now, the cool thing about equations is you do not ever have to come up and be like, is this right? How can you tell if it's right? Put it back in. Take the x out right here. Put a 2 in. 2 minus 7. Does that equal -5? It does. So you can move on with complete confidence that you are good. What are your questions? All right. Part B. All right, variable is on the right side this time. Makes it look a little different, but it's the same process. How would we undo adding 13 to the W? Subtract 13. So we're going to subtract 13 from both sides. The 13s are going to go away, but what's -7 minus 13?
20.
-20. The signs are the same. We add the numbers to keep the sign of the larger. We don't ever leave the answer like that. Go ahead and write the variable in the front. What are your questions? All right, here's part C. We have 3 times x equals 33. Remember, a number right next to a variable is multiplying. How would I undo multiplying by 3? We divide by 3. 33 divided by 3 is 11. You can cross those 3's out on the left. You just have the x equals 11. Questions? All right. Here we have x divided by 3, and that equals a negative 15. Yes, to undo dividing by 3, we multiply by 3. So times 3, you can cross those 3's out on the left. That leaves me with just the x. What is negative 15 times 3? Negative 45. Very good. And raise your hand if you have questions. All right, what should I do first? Very good. This is multiplying at the moment. Negative 5 times y. We undo multiplying by negative 5 by dividing both sides by negative 5. You can cross out those negative 5's on the left. Leaves you with just a y. And what is 25 divided by negative 5? Negative 5. Good. What are your questions? All right, so I have w plus a negative 7 equals 13. How do you think we're going to undo adding a negative? Adding a positive. Good. Remember, we're wanting those to cross out, to equal a plus 0. So we get negative 7 or minus 7 to 0 by adding 7. All right? It might help you to rewrite it like that first. Then it makes it a little more obvious that adding 7 is how we're going to undo it. Okay, so either way, if you want to write it out again or if you just want to go right to the plus 7, I am cool with either one. Those are going to go away. W equals what? 20. Good. Raise your hand if you have questions. All right, here's G. Getting a little chatty. This one might be another one where if you want to like rearrange it, write it a little differently, it might be helpful. But we're trying to undo adding a negative 15. How do we undo adding a negative? Yeah, we're going to add a positive. Good. Again, when you're doing adding and subtracting, remember your goal is to get it to 0. Multiplying and dividing, your goal is to get it to 1. We're using those identity properties. All right, so negative 15 plus 15 crosses out, goes to 0. What is negative 6 plus 15? 9. So 9 equals y, or y equals 9. Questions? All right, here's where the fun really starts. All right, there's a lot of talking. Does that mean there's a lot of ideas? Yes. All right, what are we going to do? Multiply by the reciprocal. Good. Remember, the goal is to make it a 1a on the left. We do that by multiplying by the reciprocal. So we flip the fraction, multiply both sides by that. That works because the 3's simplify to 1's, the 2's simplify to 1's, and then we just have a 1a. But remember, this is a balancing act, so it only works if you do it to both sides. So on the left, all that's gone, we just have the a. On the right side, what is 4 and 2 going to do? Yeah, and it becomes what? 2 and 1. And then 2 times 3 is 6. That's where the 6 came from. All right, 13 equals W minus negative 21. What's a minus negative? A plus. I would definitely rewrite this one. Now it's easy to see that we do what? Subtract. Subtract. 21. Good. I was waiting for someone to say 21. All right, what is, bless you, what is 13 minus 21? Negative 8 equals W, or W equals negative 8. Lots of rearranging and rewriting on this one. What are your questions? All right. Getting a little tricky again. As you are writing this, I want you to think of what sign is with the 15. It is currently positive. So would adding 15 get rid of it? No, that's a very common mistake here. As soon as students see a minus sign, they want to add. You cannot add 15 because you would end up with a 30. That's not what we want to do. So how are we going to move this guy over here? Subtract. Any questions on that idea? Remember, we're trying to get the A part by itself. We got to move the positive 15 up out of there. All right. Now, does the negative just go away? That's with the A. No, that's the other thing people do. Once the 15's gone, they just drop the negative along with it. It doesn't work. That negative is part of the A. Any ideas now? Yes. Yes, this is like a negative 1 times A. And we undo multiplying by dividing. So this is actually our first 2-step equation. It looks like a 1-step equation. That's why we put it in with the 1-step equations, even though it's like a hidden 2-stepper. Okay, so you got to first get rid of the positive 15. Then you got to get rid of the negative 1 by dividing. This is one where I would definitely plug it back in and see if it makes sense at all. You would have 15 minus a negative 2. What's a minus? Negative? A plus. 15 plus 2 is 17. Good. What are your questions? All right. Here is K.
Oh boy.
Now, parentheses always make me want to distribute. Is there anything to distribute here? No. If there was like a 2 right here, then that's where we'd start. Like multiply, multiply. There is nothing we can distribute. There's nothing we can combine inside the parentheses because they're not like terms. So are the parentheses doing anything? No. They're just there. I don't know why, just to bother us. Like a little nap. What?
We have to do that first though.
Do what?
Parentheses.
What can you do with the parentheses?
Make the 7 to 0 by minusing them out.
Nope. I mean, you could. You're just going to do more work. These parentheses are pointless. I don't know how else to be nice about it. They're not doing anything productive for this problem, okay? What we can do is just add these two numbers. They're on the same side of the equal sign. They're like terms. Put them together. 7 plus 2 is 9. Now what can I do? Subtract 9 from both sides. So again, the parentheses are just there to throw you off a little bit on this one. Combine like terms on the left. Use inverse operations to isolate your variable, and you're done. All right. All right, ideas.
Get the these numbers to improper fractions.
Yes, so I want to make these improper fractions. So I'll do 3 times 2, that's 6, plus 1, that's 7. 7 times 4, plus 5. That's 28, plus 5 is 33.
Yeah.
Now what? Multiplied by the reciprocal. The reciprocal of 7 over 3 is 3 over 7. What's 33 times 3? 99. What's 7 times 7? 49. Good. Now, these are a little bit harder to plug them back in and check, but that's where the calculator comes in handy. If you got that TI-30 that we talked about or any of the similar versions, you can type calculators in, so you can check these. Even though they're not as quick in your head, you can still check your work. Questions on the front of your notes? All right, flip those bad boys over. All right, now is there anything I can do with the parentheses?
Yes.
Yes. What is it? Sorry, I didn't fall. I was just moving my chair very dramatically. What can I do? Yes, I can distribute this -1. Okay, it's like multiplying everything in parentheses by a -1. So I still have my 3. Still have my equal sign. Still have the -2. But now it's going to be -1 times x, which is -1x or minus x, and -1 times -4, which is plus. Good. So you're basically just switching all your signs in the parentheses when you distribute the negative. Now, do you see how I have 2 regular old numbers on the same side of the equal sign?
Yeah.
That means I can combine them. They're like terms. So what is -2 plus 4?
2.
Positive 2. Good. So combine those into a plus 2. All right, now what?
Oh,
Subtract 2 from both sides. What is 3 minus 2? 1. Now, I still have this little sneaky little negative. Divide by negative 1. Good. You need to divide both sides by that negative 1 to make the x a positive. And a regular 1 divided by negative 1 is just going to be negative 1. And then, of course, we rewrite it. This is one where I would definitely stop and check. If you put negative 1 in here, negative 1 minus 4 is negative 5. And negative 2 minus negative 5 is like negative 2 plus 5, which does equal 3. I don't need to see you check it, but it is extremely helpful if you just stop and do what I did. Sort of talk yourself through it. You can make little notes off to the side if there's a little too much to do in your head. It literally takes 10 seconds and it can fix all your mistakes, or at least make you aware that mistakes are happening so you can go back and try again. Questions? All right, here is n. All right, how do I undo multiplying by a fraction? Multiply by the reciprocal. What's the reciprocal of 3/4? 4/3. So I'm going to multiply both sides by 4/3. Goes away, goes away. What do I get? 8 over 15. Good, 8/15. Awesome. All right, we are now going to get into some word problems. You ready? So you can see in your notes, it has the steps that we're going to follow. Step 1, it says to write a let statement. A let statement is where we all decide what variable we're going to use. So we're going to let x or n or whatever you want stand for our unknown value. Okay? Step 2 on your notes says to write an equation that represents the situation and then solve it is step number 3. So our first one is a let statement. I am going to let n equal a number. Every year, do I have to write a let statement? You do have to write a let statement, okay? Anytime you have a word problem, you're going to see a let statement or a place where we're defining the variables. 82 decreased by a number is 198. I always find my is. That is where I sort of think of it as like a break. That's where your equal sign happens. Figure out everything before, equal sign, everything else. Okay? So 82 decreased by a number, and I'm going to let n be that number. So what does the left side of my equation look like? 82 minus n. Then is becomes my equal sign, 198. Now I solve. How would I solve this? Subtract 82 from both sides. Negative n equals 8 minus 2 is 6. 9 minus 8 is 1. We have another one, so 116. Am I done?
No, ma'am.
No. What do I have to do?
Divide by -1.
Divide both sides by that -1, and you get that n equals negative 116. These are a little harder to check. You have to assume you wrote the equation right. So you can plug it into the equation you wrote, or you can read through the situation and see if it makes sense. All good options. Questions? All right, here is example 3. 22 more than a number is 31. I'm going to find that number. First thing I want to do is a let statement. Let N stand for that unknown number. 22 more than a number is. Let's do that, all that part first. What is more than? Plus. 22 plus. What's my number? N. Is my equal sign. And then the right side of the equal sign is easy. It's just 31.
Wait.
Yes.
Wouldn't it be the N in front of the 22?
This is always a common question, and we don't really talk about it much because addition is commutative, so it doesn't matter. But yes, similar to like less than, we usually switch the order. More than would be the same idea, only it doesn't matter, so we don't even really worry about it. So yes, if you had N plus 22, that's probably more correct, but they're the same thing. All right, then what? Subtract 22 from both sides. N equals 9. What are your questions? Example 4.
Let's say 4.82.
4/3 of a number is 4.82. Find the number. All right, I'm going to let A be the number this time. So let A equal a number. If you already wrote let N equal a number, you go for it, okay? 4/3 of. Do you guys know what of means? Multiply. So 4/3 is just a fraction. Of means multiply. A is where my equal sign goes. 4.82. Now, here is where I personally would get my calculator out. I do not want to mess with converting decimals, fractions, all that nonsense. I don't feel like it's a valuable use of your time. Honestly, this is not something I would even bother doing by hand. Go ahead and spend that $12, okay? What should I do to both sides? Multiply by 3/4. Those go away. In the calculator, you will do 4.82 times. Do you all know the ABC button? To enter 3/4 into the calculator, you would hit 3, and then this guy, and then 4, and then your equal sign, and it does all that heavy lifting for you. Was anyone able to come up with that on the calculator? Very good. I think it automatically gives you a decimal answer. Yeah, anytime you type in a decimal, I believe the output will also be a decimal. If you are struggling with typing it in, great. If you are one of those people that chooses to do this by hand, I think the easiest way to do it would be to convert 3/4 into a decimal, and then just do old school by hand decimal multiplication. If you want a private lesson in that, I can totally give it to you. I just, again, don't see it as being a super valuable use of our time. And other teachers don't agree with that, and that's just fine with them too. All right, last example of the day. John paid $7.25 for a hot dog, a bag of chips, and a soda. If the hot dog cost $3.50 and the chips were $1.10, how much did the soda cost? So, yes. Did you have your hand up? All right, I'm going to let C be the cost of the soda. When you're buying something, let's say you're buying a hot dog, chips, and soda, what do you do with all the individual prices to get your total? You add them. That's what we're going to do here. So, first, hot dog, $3.50. Chips, $1.10. Soda is my unknown. I'm calling it C. If you want to call it S for soda, that's fine. Equals the total. Now, I have some like terms here. What should I do with them? Add them. 3.5. You can drop the 0 at this point if you'd like. Plus 1.1. Yes, 4.6. Or 4.60. Then what? Minus, again, calculator, probably super helpful right now. If you're doing this by hand, remember to line up your decimal points before you start subtracting. So 5 minus 0, you'll have to borrow. 12 minus 6, and then 6 minus 4. What is it? Very good. And then this is where you have to go back and remember what you're talking about. If you're talking about money, you need a dollar and a decimal sign, or decimal point. Dollar sign, decimal point. Also with money, make sure you have 2 numbers after the decimal. It just happened naturally on this one. Sometimes it doesn't. Don't tell me like $2 and 0.6. That's not how we do it. So just be aware of that when you're giving your final answer. Any questions? Seems like an expensive soda, doesn't it? All right, what did we learn about today? Very good. Yes, every day we summarize these. Honestly, I did not get a chance to grade notes first chapter between level changes and everyone's tests all fell on the same day. So I actually graded all my geometry students' notes this time. Chapter 2 will be your turn. So just make sure that you're getting your notes done, highlighted, and summarized each day. Those are the 3 things that I look for. Here comes your homework. Any questions?